Jeon. I'm a PhD candidate in Yonsei University and from South Korea. Today, I will talk about the named entity recognition from noisy text from the defect complaints. And here is the contents, and I will start with the noisy text in the background. Look at this picture, and is there anybody who has never seen or never used this acronym? Okay, so not only this acronym, but also we already use many noisy text like punctuation symbols or typos, or even the slang in our daily life. And all of these non-standard expressions are noisy text. And these noisy texts help us efficient communications, but sometimes make us difficult to understand. What about in construction sites? I will focus on the defect complaint text, which is one of the representative noisy texts produced in the construction site, and especially in the apartment building by angry residents because of the defect. And you can find very unfamiliar words in the example of the defect complaint, especially collected in the South Korea, but there are a lot of slangs and even some abbreviations or symbols and some words describing the kinds of just describing the defect phenomenon, because the residents are not expert in the construction. But to effectively respond to the angry residents, we need to extract the essential defect information from these kinds of the noisy text. So what we want to do is to extract the essential defect information using the named entity recognition technique. But the problem is that this kind of linguistic noises also indicated the essential defect informations. But the existing named entity recognition techniques discarded most of these linguistic noises in the pre-processing stages. So we cannot detect these linguistic noises as the information, and we need to keep them for the NER. So let's start with the named entity recognition from the tokenization, which is the process of the noisy sentences divided into the smaller unit named the tokens. But if we use the normal tokenizer, these kind of noisy texts are not in the vocabulary of the existing tokenizer. So all of these noisy texts replace to the one same unknown token. And these unknown tokens lead the out of vocabulary problem. And these out of vocabulary problems make the NER very difficult and the performance is degraded. So to address this problem, this study proposed developed a thesaurus and the tokenization using this thesaurus. To develop this thesaurus, most frequently occurred noisy patterns can be extracted by the rule-based, like regular expression or such kind of a programming. But still, we need to manually extract these as many noisy text as possible and define it in the thesaurus. And also, we developed the domain-specific tokenizer to successfully tokenize the noisy sentences into these valid tokens in the pre-processing stages. And after that pre-processing stage, we need to fine-tuning the language model. And before the transfer learning, these tokens need to be embedded in each language model. But there are still some rare words did not exist in the vocabulary of the pre-trained language model. So these tokens need to divide it to much smaller unit called the subword. So here is the proposed method, and I hope that this is the one, if you remember, understand from my presentation. The most important thing is that okay, let's look at the detailed example here. So if the noisy sentence is input, our developed thesaurus and the domain-specific tokenizer can split each sentences into the valid tokens. And then before transfer learning of the language model, some words or typos should be split into the much smaller words named the subword. And here is the example of the subword tokenization result. And this study compared the 3 language model and the two subword tokenization method. One is the WordPiece, and the other one is SentencePiece. And the primary differences between this subword tokenization is the preservation of white space. But when it is very crucial to morphological analysis to handle the agglutinative language like Korean or Tamil, because they are have the morphological through the morphological analysis we extract the meaningful part of the words which name the stems, and we define these unchangeable part defined in the thesaurus. And in terms of the transfer learning, the subword tokenization is conducted before the embedding stages. The subword tokenizer allows each language model can capture and learn the rare words. And here is the result of the experiments. And this study found that the SentencePiece subword tokenization method with the Korean pre-trained BERT achieved the highest performance, but this result can vary depending on the linguistic features. So what is more important to if you face a noisy text of any language in your project, you can apply just 2 things. So first one is you can develop the thesaurus, and applying the thesaurus and compiling the domain-specific tokenizer. It is very important and even helpful to your noisy text to display the valid tokens. And yeah, and also there are so many noisy texts, and the noisy text grows every single day, so we cannot define all of them in our thesaurus. So we need to train a pre-trained language model to detect the irregular and unpredictable noisy text. So, okay, I'd like to conclude my presentation, the following contribution and feature works. Okay, thank you. Any questions and comments?